Welcome, everyone, to Driving Impact with AI, use cases and best practices. I'm thrilled to have you here as we explore how AI is reshaping industries, driving efficiency, and unlocking new opportunities. Today, we'll dive into real world applications and share best practices that you can implement right away. Whether you're leading digital transformation or just starting your journey, this session is designed to empower you with actionable insights. Throughout the session, we'll explore real-world applications and best practices. Joining me today is Anudeep Kantanguri. Anudeep is a seasoned technology executive with extensive experience in leadership roles. He's the Chief Technology Officer at Skillo, and he has been instrumental in driving innovation and delivering exceptional IT solutions to clients worldwide. Thanks for joining today, Anudeep.
Hey, thanks, Brett.
Throughout the webinar, he's going to share some best practices and examples of what his clients are looking for when they want to staff their IT projects and their AI initiatives. And he also has a lot of examples of AI in action. So I look forward to hearing from him. So one of the things that we want to talk about is AI as a catalyst. It's not a magic silver bullet. It doesn't fix everything. It accelerates whatever foundation you already have in place. If your data is disorganized, your governance is weak, and your strategy is unclear, AI will only magnify those issues, making inefficiencies worse. But if you have structured data, strong governance, and digital maturity, AI becomes a force multiplier, driving smarter decisions, optimizing workflows, and unlocking new opportunities. AI thrives on well-organized and high-quality data. Without it, outputs become unreliable. Threat detection, data processing, and hierarchy are crucial. Governance, compliance, risk management, and privacy are foundational. If AI operates in a weak governance structure, the risks multiply. AI is only as effective as the people using it. Readiness, adaptability, and continuous learning ensure that AI enhances and not disrupts your organizations. So, are you setting up AI for success? Are you thinking these things through? Let's talk about that today. One of the resources that can help you is the best-selling book, The AI Lead, where I delve deeply into what I call the forces of flight in digital transformation. Half of the book is dedicated to strategy and business, how AI can be a catalyst for growth. The other half is technical, covering essential aspects like data management, tagging, data in motion, rest, and ethical considerations we need to keep in mind. At the heart of this book is the concept of overcoming data drag. It's the key to understanding and managing the foundation of AI, which is data. Achieving digital dominance requires both addressing data strategy and people strategy because they're equally important. AI is a powerful force, but there's one thing that can hold it back, and that's data drag. Just like an airplane facing resistance when taking off, organizations experience data drag when poor data quality, fragmented systems, and inefficient workflows slow down AI adoption. Think of data drag as the hidden villain in your digital transformation story. It's the reason why AI efforts stall. Data drag shows up in the form of poor data quality. Remember, garbage in and garbage out. Data drag also comes from a lack of standardization. Inconsistent formats and disconnected systems makes AI struggle to find the patterns. Data silos. When departments hoard data or isolated data pockets, AI cannot see the full picture. And the consequences can be severe, increasing vulnerability to attacks, compromising data quality, and slow threat response. But here's the good news. We can overcome data drag. The key is to treating data as an asset, not an obstacle. No data, no AI. You want a connected, clean, and accessible data platform. And by implementing strong data governance, consolidating strategy, and having AI-ready workflows, you can remove data drag. The question is, are you ready to remove those barriers and accelerate AI success? And that's what we'll be talking about today as we explore different use cases in AI. Now that we've overcome and discussed what it takes to overcome data drag, let's look at a real world example of how AI is transforming transportation. In the AI lead book, I explored how AI powers route optimization and dynamic pricing to make transportation services more efficient. Let's break that down. Imagine handling 300,000 events per second, managing terabytes of data in real time. That's the challenge like companies like Lyft or Uber or Wave and also logistics providers face every day. Key questions come up. How do we map our data? How do we enhance safety? How do we streamline analysis? How do we detect and respond faster? This example is critical because companies like Uber can use AI and machine learning to predict demand and adjust fares in real time based on supply and demand. It also forces and creates better route optimization, helping drivers take the fastest and most efficient paths to analyzing traffic patterns. Well, that sounds great, but how would you do that? Let's take a look at what an AI powered transformation system architecture might look like when handling 300,000 events per second. This is quite a use case. The system is designed to ingest, process, store, analyze, and act on vast amounts of data. This is what a speed layer looks like in the AI lead book, and a speed layer can overcome data drag. At the foundation, you have data ingest, then you have processing, a processing layer, storage layer, analytics and decision layer, and finally the interface to web apps and other applications where users can get the value. This end-to-end AI-driven system enables transportation networks to function efficiently, respond in real time, and enhance customer experience. On the business side, if you're not familiar with all of these technologies, that's okay. The concept here is to ingest the data, process the data, make sure you have the right storage approach, and then make those decisions and provide that impact to users. Anudeep, what are some of your thoughts that you have on this particular use case? Any stories that you want to share?
Sure, Brian. Thanks for just putting it into words like how digital transformation is changing the transportation industry and how uh, Uber is using all these technologies to prosper in transportation realm. So let me just take an example of my recent client where it's a large trucking company. So they had their data sitting in their data warehouses, the legacy data warehouses, and they don't know like what to do with the data. So we stepped in, and what we did is that we changed everything into a real-time streaming. So we implemented Kafka, which you just shown here in the data ingestion layer. So in trucking industry, what happens is that whatever you take like order, balancing the warehouse, everything is an event. So those events are streamed into your storage layer. So before going into the storage layer, like how do you pre-process the data? So in my use case, what we used is we leveraged whatever the company already had. So they had Azure cloud in place. So we used Azure Databricks for storage and pre-processing layer. Um, we took this Databricks and we use Spark to build analytics over it. So the analytics, basically what they tell you is that they had their Zonar geotab data flowing in, which are like real-time trucking, so where the truck is going, or the GPS data. So with those data, we try to predict like what route the truck needs to take. Say suppose in route A, there is some obstacle, so the truck can take route B. So this all comes with the real-time streaming, and this is already published through the truck driver before he even knows it. So such type of things, when you optimize, what happens is that the company saves a lot of time, saves a lot of money, the truck driver saves his effort. So these things are very valuable for an organization to grow.
Yeah, I appreciate it. Let's take another example. Let's take a look at healthcare. Let's look at this use case in the context of using AI to drive predictive diagnostics. Think about this. When hospitals and clinics are handling millions of patient records in real time, AI can play a crucial role in improving diagnostics, optimizing treatment plans, and enhancing overall efficiency in patient care. In healthcare, processing vast amounts of data like medical imaging, historical records, et cetera, this can require a lot of information and data, and it comes with significant challenges. For example, how do we identify patterns, or how does the hospital enhance diagnostics? How can they optimize patient treatment plans or ensure AI recommendations align with actual medical expertise? AI can address these challenges by analyzing data sets, detecting early disease markers, and predicting treatment effectiveness. Machine learning models can detect anomalies. Natural language processing can help analyze patient records to identify trends. And AI driven automation can improve hospital workflows, reducing administrative burden. This AI driven approach enhances accuracy, reduces time to treatment, and improves patient outcomes. By leveraging AI, the healthcare industry can move towards a future that's faster, more precise, and more personalized, all while maintaining the privacy and security of patient records and personal information. So let's take a look at what this speed layer might look like. This speed layer architecture from the book is an example of ingesting and processing and analyzing data, just like the transportation industry. But here we have a healthcare example. So we have healthcare data sources. If you think about it, there are a lot of medical devices. So there's EHR, electronic health record systems, medical imaging, lab results, wearable data, Internet of Medical Things and IoT, connecting real time health devices. Then you have data integration. Just like we had in the transportation industry, we have to integrate and standardize the data. We can use different adapters, different ETL pipelines, that's data pipelines, extract, transform, and load pipelines. Then again, you have to process that information, process that data. You can use machine learning. You can use AI, such as pattern recognition. You can use different types of algorithms to do predictive models, and natural language processing, NLP, to really analyze these patient records and make recommendations. All of this requires secure storage, HIPAA compliance, personal information, protecting that, and then pushing all of that value and all of that artificial intelligence and amplifying the healthcare professionals' work through diagnosis, personalized treatment plans, risk scoring, clinical alerts, validation, right? So this is a way in which to capture the value of these devices and then ultimately improve accuracy, personalization, and patient outcomes. So it's the same type of flow in our speed layer where you have to ingest this information and data. However, the models, the storage, the integration techniques might be a little bit different. Andy Deep, what jumps out to you in a architecture like this for healthcare?
Yeah, in healthcare, yes, Brian, I guess you have covered all the things. So when it's healthcare, what people will think is basically compliance, governance, security. So be like being a patient, you don't want your records to go out. Okay, so in your speed layer, that's what we'll do. So once the data goes in, right? So the healthcare organizations, what they need to do is encrypt this data. So you have a lot of PII data. How do you encrypt it? And what are the governance policies and compliance we need to follow? So one good example is you can create a RAG chatbot. So where you train internally all the documents which say suppose there is flu is predominantly uh, mostly many people get it, right? So the medication for flu can be trained in, and you don't need a doctor to prescribe the medicines because it is already trained on that. So the only things you need to take care here is security, compliance, and governance. So I feel we need some people who are like data governance people in AI and data security people in AI. So those people are very important in this type of scenario.
Yeah, that's great points. And from your perspective, how easy is it to find people who can operate and manage and develop in this type of speed layer?
So, yep, to answer your question, it's pretty hard, right? So we have people who are in data governance, but we don't have people like a lot of people in AI data governance, because AI data governance rules, all the organization are still figuring out how do we do that? How do we keep them in place? So this is a challenge right now.
Yeah, absolutely. I totally agree. And maybe we can have some advice at the end of this webinar on how people can develop their skills to elevate in order to become a little bit more technical. And I think that's really the one of the key things that I find in these use cases is that everybody needs to be a little bit more technical in what they're doing, and then you need some deep expertise as well in certain areas. And I think we'll start seeing a pattern here as we go through some of these other industry use cases. So let's talk about finance and, more importantly, the concept of AI powered fraud detection. That's really transformed the finance industry. Every day, financial institutions process millions of transactions, making it critical to detect fraud in real time. The challenge there is that fraudulent transactions can cost banks millions of dollars, billions of dollars annually. AI helps address five key challenges, such as recognizing fraudulent behavior patterns, automating risk assessments, reducing false positives, balancing security with the user experience, and scaling fraud detection to handle global financial transactions. AI can help analyze those transaction data in real time and identify unusual spending patterns that might indicate fraud. Machine learning models are constantly running to look at anomalies by comparing transactions against your typical user behavior. AI driven risk scoring can assign a fraud likelihood score, triggering instant action for high risk transactions. Continuous learning algorithms can adapt to new fraud tactics, making detection more sophisticated. And then network analysis can detect large scale fraud rings by connecting patterns across multiple accounts. This type of AI driven approach can enable financial institutions to detect and prevent fraud faster, reduce false alarms, and enhance security without disrupting the customer experience. So let's talk about that speed layer. Again, we're going to have data sources. We're going to need to ingest those sources from payment gateways, core banking systems, card networks, mobile banking platforms, e-commerce platforms, right? This data source layer, that data needs to flow into a fraud detection system at scale and in real time. From there, the data has to be ingested. Again, we're at real time transaction ingest. This ingestion layer is responsible for handling and preparing transactions. Again, we have applications for that to analyze these flows with really millisecond latency, extremely fast, right? And that ability to do that requires obviously a lot of engineering. Then from there, the transactions will need to move into a fraud detection engine. This is an AI powered engine to process transactions, use multiple techniques. What that engine is looking for is anomalies, fraud patterns, irregular spending behavior, etc. Machine learning models can adapt and learn about new fraud tactics. And then feature engineering can enhance fraud detection, such as based on historical trend analysis, even geospatial, zip code, geospatial latitude and longitude transactions. And then you can map out and use graph databases to help analyze relationships between fraudulent entities. And all of this happens in extremely fast manner. From there, the risk scoring and decision happens, the calculation using probability, the ability to apply predefined fraud detection rules, using secondary verification methods to reduce false positives, and figure out if humans need to be in the loop or departments need to be in the loop to get involved, or whether or not to, turn off the card, so to speak, or turn off that point of sale system. Financial institutions have to balance security with the user experience. Nobody likes their card getting shut off in the middle of a transaction, but sometimes it's in your best interest. The rules around that are critical. And that's where the final stage comes in the response and feedback loop, real-time alerts, customer verification, case management, and then the ability to learn and continuously retrain the process. That happens in this feedback loop. And all of this needs to maintain PCI data, anti-money laundering rules, and knowing the customer. So this AI powered fraud detection system that we're showing on the screen, this speed layer can operate in real time and ensure a seamless banking experience that really protects the interest of consumers. So this is on paper what it would look like, this speed layer. One of the things that's really critical here is this, the fraud detection engine itself, and being able to set that up in a way that has zero latency and a high fault tolerance and is accurate. So, Andy Deep, what kind of pops to your mind here on the financial fraud detection system, or what have your clients talked about in terms of being able to do this?
So, hey, thanks, Brian. So in AI, right? AI in finance transforms operations end to end, say, suppose from customer interaction to risk management, as you have covered. So it begins with personalized customer experience through AI-driven chatbots and recommendation engines. So these are some things which have put in place for our financial clients. So again, in finance too, what comes to your mind is data encryption. How do you encrypt data in transit, and how do you encrypt data at rest, and how do you build encrypted pipelines? So AI enhances this fraud detection by analyzing transaction patterns in real time. So so when you say real time, so you can say like RabbitMQ, Kafka, which stream the events on real time. So that flags anomalies using the machine learning models, which you have just showcased. So in credit scoring also, right? Machine learning models assess credit worthiness more accurately using this alternate data. So finally, AI-powered predictive analytics helps these institutions to forecast market trends and manage risks. So this end-to-end integration boosts optimization, efficiency, increase security, and decision making in finance. So that's the way the leaders think right now. So one more other use case which we have put in place, this is for a bank in Peru. So we took in all the IoT, like the Twitter data, and we fed into our model, naming like negative, positive. So using NLP and Navy base. So apparently the end result is the bank could see what the customers were talking about, like is it in a positive way or negative way, so that they can change what is, like, say suppose their credit cards are not good enough, so it marks as negative, so labeling the data. So this is one broad use case which we focused on, giving the bank the trust of their customers.
Yeah, that's great. And you think about being able to instrument that and architect all that, especially in a widespread international banking system, and also in the context of many mergers and acquisitions, the technology piece of this is critical, and it's a lot to figure out. We hear this a lot. Oh, that's a lot to figure out. And I think what we'll do is we'll have some recommendations here towards the end of the webinar about how do you scope these things down and how do you do the process work in order to figure out how to make this work. And a lot of people, I think myself included, tend to think in terms of the massive scale and how do we do this with millions or billions of transactions. And I like to remind myself that if it doesn't work for one transaction, it won't work for a million transactions, right? So it's like, how do you make this all work for one? If you're going to try something new, if you're going to introduce a new tool or introduce a new policy or introduce a new process, starting extremely small and having a robust, test and piloting approach is really critical in a system like this.
Absolutely, Brent.
So let's go to the next use case, which will be in retail here. And when you think about retail and e-commerce, retailers face several challenges in how they drive personalized recommendations. Really, this idea of relevancy. And when you think about relevancy, it comes down to what does the customer expect, and how do we map into what those customers and buyers expect? So how do we recommend relevant products? How do we analyze user preferences? How do we analyze and balance AI-driven promotions and offers with human curation? How do we optimize inventory, et cetera? AI can enable retailers to personalize each touch point while ensuring efficiency in inventory, marketing, and customer satisfaction. The challenge in that is the ability to bring together AI with customer habits and understanding the individual behaviors of each individual person, including their purchase history, their search behavior, etc. We appreciate those individual personalized efforts. At the same time, these suggestions can improve the shopping experience and actually help us find things that perhaps we didn't know about before. In that context, things like personalized recommendations, promotions, even offers for like products that might be of interest, all of these require machine learning algorithms and filtering and deep learning from an AI perspective. But you can get rest assured that Amazon, Walmart, Shopify, they all leverage AI powered recommendation engines to improve that customer experience. The future of retail is really smart and predictive and deeply personalized, all thanks to AI. So how does that work? Let's take a look at the speed layer for retail and e-commerce. AI is transforming that retail experience all based on personalization. The speed layer that we want to deploy needs to process, in this case, billions of customer interactions. And again, provide that real time, hyper personalized shopping experience. If you think about it, there's also the seasonality of retail, such as peak traffic periods like Black Friday or holiday sales. So, in this regard, we want to focus on the customer interactions first. We want to think about the customer touch points across various platforms, such as web storefronts, mobile apps, internets of things like smart home assistants, physical stores, social commerce integrations like on Instagram or TikTok and Facebook, wherever customers can discover new products. These channels generate vast amounts of data, which is collected and processed in real time in our speed layer. Data collection also needs to occur. Once interactions happen, real time data is collected and the processing can begin. Clickstream data, purchase history, search behavior, analysis, and social signals can all detect customer sentiment, reviews, and trends. Data must be normalized and fed into the personalization engine in the next layer. And that personalization engine is an AI driven, AI powered solution that really looks at the customer profile with a 360-degree view, making recommendation models such as collaborative filtering, like customers that are like you, suggestions, like others have bought suggestions. Content-based filtering and deep learning models can adapt recommendations based on your history and what's in your cart. And then there's finally the optimization engine, which is providing visuals and content to consumers based on their trends and figuring out which one works better. For example, which ad might work better, which product promotion might work better, which cover art might work better in a certain use case. To support the real-time personalization, a robust data infrastructure is needed. You need a real-time data store with sub-millisecond recommendations. You need probably a data lake for historical trend analysis, high throughput, again, event streams and high velocity, zero latency event streaming, distributed caching for faster access to product and data across different channels. And all of this equals a closed loop, personalized experience in delivery, such as product recommendations, dynamic pricing, targeted offers, email and push notification, and consistency across all your omni-channel touch points. This AI-driven architecture can enable retailers to increase engagement, drive higher conversions, and enhance customer satisfaction. An example of this is if a customer is shopping on Amazon, for example, and browses a bunch of horseback riding gear, and perhaps they are interested in a certain helmet, but doesn't buy it. Maybe they move it to their cart and it sits there for a while. These systems can actually drive internal processes to to pre-position likely purchases closer to the customer and actually move into fueling decisions and processes that have to do with delivery and providing faster service. So if somebody wants to buy a riding helmet, perhaps these retailers know before the customer actually does. So Andy Deep, what do you think about the retail personalization piece and the speed layer there? What type of things have you seen, or what type of roles have customers been focused on as they look at deploying more personalized experiences?
Yep. So Brian, in retail logistics and e-commerce industry, right? So there is a lot of flow of orders and a lot of flow of distribution centers, like the stock keeping. We need to keep updating the stock. If the stock is less, or if the stock is more, then you have to ping your third-party truck drivers to distribute between the distribution centers. So these are some problems I have seen in retail industry. Um, so so the talent which is lacking here is like, so they have Python developers and all, but they don't have like a AI solutions architect, so who can bring his expertise in machine learning as well as architecting the solution through AI. So what we recently with my team, so we already have AI solutions architects. So we for a small retail industry, we have developed chatbots, AI chatbots, which handle queries, process returns, provide 24/7 support using NLP models, like leveraging enterprise edition of OpenAI's ChatGPT. So that when I say ChatGPT, again, there's like data governance analyst, which you need to have on your team, like define the rules across, like your data, being a retail client, your data needs to stay in the organization. So you need to take care of that. So other use cases which we have used are fraud detection, post-purchase engagement, dynamic pricing in retail.
Yeah, that's great. Great points there. I understand also what you're saying with regard to having the right type of data governance. All of this, as we've talked about, AI is really underpinned by a strong data strategy, and I think people have always talked about, and we hear it frequently. Data is critical. Data is the new oil. Data is fuel, and it's amazing that even in the AI age, how companies seem to understaff or under resource the data aspects. What are some of your thoughts on the resourcing constraints there, and why does money maybe get invested in AI chatbots as opposed to tackling the data drag or the data layer?
So it all depends on the leadership, what decisions they take in the organization, Brian. So firstly, we need to educate them and let them know that AI is not going to ruin their organization. So it's just making them better, efficient, and which optimizes things. So once they know it, they can go ahead and invest in the technology and invest in training personnel. Say, suppose like a data governance analyst can be trained as an AI data governance analyst with some training from the company. Um, Similarly, right, when you have SQL, Python developers, they can be modeled as an AI machine learning engineers. So I would say at the end it depends on the leadership calls, and it depends on what type of training they're gonna give to the individuals, and yeah, that makes a big difference.
Absolutely. All right, let's go to our last use case here, and we're going to the seventh different industry. Let's go to manufacturing and explore how AI powered predictive maintenance can transform manufacturing and industrial operations. If you think about it, factories rely on expensive and complex machinery, and unplanned downtime is a real problem. It can result in huge financial losses. AI can help predict failures before these even happen. Manufacturers face several challenges in maintaining industrial equipment health, such as when will these machines fail, or how do we reduce unplanned downtime? How do we optimize maintenance schedules and improve operational efficiency through automation? How do we integrate AI-driven insights with our human decision making? By using real-time monitoring and AI analytics, manufacturers can shift from reactive to proactive maintenance strategies. AI can collect data from IoT sensors embedded in industrial machines. For example, it can look at vibrations, temperature, energy consumptions to detect early warning signs of mechanical failure. Uh, these devices can also use real time operational data to predict when maintenance is required, rather than relying on fixed schedules. AI can also leverage machine learning models to identify anomalies, and automating maintenance scheduling can ensure that repairs happen before breakdowns occur. With AI powered predictive maintenance, factories can minimize disruptions, improve safety, and extend the lifespan of their equipment. Companies like Siemens, GE, and Bosch are leveraging AI driven predictive maintenance to cut costs, improve efficiency, and reduce downtime. So let's take a look at a speed layer there to understand how AI driven predictive maintenance would roll out and what it would look like to enable real time monitoring of industrial health equipment. This speed layer here integrates IoT sensors, machine learning, and edge computing to predict failures before they occur. That means that devices have to collect data at the factory floor. This all starts with the factory floor and collecting data there, IoT sensors, supervisory control and data acquisition systems, SCADA systems, PLC integrations, environmental sensors. All of these things can help provide real time data, and even think about things like ambient factors like humidity or air quality that can affect machinery. This raw data continuously is ingested in the speed layer and must be processed and data, and also that data needs to be prepared. So edge gateways, signal processing, data normalization techniques, and MQTT transformers standardize industrial protocol communications. So if you think about it, how do the machines talk together? How does the data need to get standardized? How do you pull it in to identify anomalies? That means that these machines also need to be able to produce volumes of data, and then that data must be stored for historical purposes, as well as to see what's happening over time in linear progression through time series data. The system then will store and organize both real time and historical data to create not only a historical view, but also then fuel AI driven predictions to help manufacturers detect patterns. And again, providing predictive analytics such as condition monitoring, vibration analysis, statistical control, etc. Finally, then allowing humans to take action through decision support, through maintenance alerts, through algorithms that provide reporting, through integration with other systems and mobile dashboards and even applications that then provide technicians the ability to make step-by-step repairs. So if you think about the use of AI to not only detect and understand what's happening on the machines on the factory floor, but the ability to provide the humans with the guidance needed to keep those machines running and also repair those machines, you can start seeing how companies are able to reduce costs, increase uptime, and extend equipment lifespan. The future of manufacturing is smart, it's efficient, and it's data driven. The data is key to ensuring that these systems stay up and that they're able to provide that core capability required by the manufacturer. So this is how I think about the manufacturing industry. And this is our last use case here. And I think it's been helpful to see all of these different use cases and how in one aspect they're all the same in that they all have to ingest data. There's still a need to prepare the data, to analyze the data, and then to inform human decision making. And you know, Deep, I'd love to hear your thoughts on not only the data level here, but anything you have on manufacturing that comes to mind would also be helpful to our listeners.
Sure. Thanks, Brian. So yeah, it has been a while We had a use case. So one client we had was in a shoe industry where they had leveraged their sensor data. So basically, um, they had sensors in their shoes, and the sensor data was flowing into their data lake. And what they did with this data, right? So they predicted when the shoe is gonna tear and when the user needs to upgrade their shoes. So like this helps in like giving them the offers way before, telling that hey, your shoes is gonna tear off in like a month, and we are gonna give you like 20% discount. So such type of use cases are what we see in shoe industry, like a predictive maintenance you can call. So here, right? So what I would again see the challenge here is you need in when you are training your data model here, you don't need to overfit the model because you only need some variables out of your sensor data which actually predict your wear and tear of the shoes. So those type of things you need to find out perfectly. So this is accomplished by a machine learning engineer. So this is the step one before you go into any AI powered, AI driven tools like which can be used for production planning, robotics and automation, energy management, data driven insights. So before that, the challenge here is what variables need to be given trained into your data model. So this is one challenge clients have faced.
Yeah, thanks. I appreciate that. So one of the things that I'd love your perspective on is let's put your CTO hat on, and there's so much hype, there's so much um, focus on AI, there's so many buzzwords. How would you go about understanding what to do? For example, let me give you a specific example. Let's say somebody comes to you in your organization and you're the CTO, and they say, well, we need to, everybody else has chat bots. We need to roll out a chat bot. Or, hey, I heard 2025 is the year of the agent. How do we get one of those? Let's go deploy agents now. Everybody else is doing it. Right. So that's kind of the business perspective, that the business sometimes doesn't understand all of the technology and the architecture. What types of things would you do to kind of redirect that energy, and also more importantly make these things work, whether it's chat bots or agents? Do you have any advice there?
Sure, Brian. So when it comes to chatbots or any agent, right? So they are just the front end. The back end is again data. So what data you feed into them. So you don't need your chatbot to give you false information, like false information to the people in organization or false information to the end users. So you have to keep in mind that data is the one which drives this chatbot UIs. And so here's why data is critical to AI too. So first thing would be like training AI models. It needs data. AI systems, especially machine learning and deep learning models, they hugely rely on large amounts of data to learn patterns, make predictions, improve accuracy. So without data, there's nothing for the algorithms to learn from. And this data needs to be correct too. So that's what I'm stressing on. And the other thing is feature extraction, like what data provides the features. Features are basically the variables which we are feeding into our subset of models, which train the larger subset that AI models use to understand relationships and make decisions. So, say for example, in image recognition, right, pixel data is used to identify objects like the relationship. It should be a close relationship. Then it's like validating and testing data. So data is split into training, validation, testing sets to ensure AI models generalize well, because you only train the data on a subset, then you put that training set on the higher data set. So without data, it's impossible to validate or refine these models. So again, the data should be high quality, diversified, which helps reduce bias in AI systems, which is a huge cause of some um, like the defects and faults. So without representative data, AI models may produce like skewed or unfair outcomes.
Yeah, thanks. I appreciate that. That's a good point. And I like to remind our business friends, no data, no AI. It's really, really critical to have your data house in order. So let's talk about now how to move forward and perhaps get started. We've explored how AI is transforming these various different industries, from transportation and healthcare to finance and retail and manufacturing. But how do you get started? Well, from our perspective and thinking about specifics, the first step really is to evaluate your current digital capabilities. Do you understand the right data is in place? Do you understand your infrastructure? Do you have a team and the skills to be able to deploy AI and to test these different examples and use cases out in a very technical way? It's important to understand the digital maturity of your organization as well. In the case of the chat bots, or in case of the AI driven agents, these AI agents, sometimes you need to have some training for your people as well, the non-technical folks. So in the case of driving forward and assessing your digital maturity, the next step would be then to address these data barriers, to make sure that you understand your data and where it exists, and if it's siloed or not, and more importantly, if data is accurate, because again, no data, no AI. The first step really is to understand that there are two main aspects of any successful AI implementation. The first is the data, like we've been talking about, and the second is the people, the technical skills of the people, but also in the business, helping everybody become a little bit more data literate and understanding the digital maturity and the evolution of these things as it relates to their job. So that means bringing together both the business side and the tech side to create an ecosystem, to create a leveraged and synergistic relationship that enhances efficiency, drives growth, helps your company adapt, and more importantly, provides long-term sustainability. From a tech perspective, that means how you build things, right? From a DevOps perspective, how do you develop technology or software? How do you deploy it? How do you determine what to automate? How do you ensure visibility and observability and security? And then from a architecture perspective, from understanding the enterprise architecture as well as your data governance. So while the business side might want to drive efficiency and adapt to new markets and drive growth and ensure long-term sustainability, the real challenge from a tech perspective is to do that within the context of your current technical architecture, and also to ensure that these capabilities, these technical capabilities, are aligned to the business strategy. Now, this is not a new concept, right? This concept has been around ever since technology has started. But the issue now is that AI requires a much more robust data infrastructure and a lot more understanding of how data moves and how data can be turned into value. So to help with that, the speed layer can be mapped out. We can take a look at the data layer and think about the outcomes we need to drive. So within all of these decisions, we have to unlock the value of data without disrupting or increasing organizational risk. What we talk about here in the AI lead book is the speed layer. And you've heard it throughout this webinar. The speed layer framework can help us think about the use of data, and more importantly, the roles of the data that gets produced, those data producers, and also the role of data consumers. And if you think about the business process between producing data, whether it's an IoT device, telemetry, computer, machine, human interactions, websites, any place that data is produced, there's always a closed loop of somebody needs to consume that data, either a human or another machine in the case of AI. So if you think about that closed loop, there's a big space in the middle, right? How does this work? How do we ensure that AI is driving the right value. That means we have to bridge the gap from producer to consumer. And in the middle, we often encounter what seems like a black box. And in that middle is data drag. And we've got to minimize this data drag. We have to be able to ingest and decrease the latency and the gap between data producers and data consumers. Think about an example. I don't know. We haven't talked about yet, but like patent law for intellectual property. How do lawyers get access to patent law and patent data and be able to do the research as a data consumer? How could we build a speed layer that would decrease the amount of time it takes to do that research from months and months down to seconds? Well, AI can help you do that. To make this transformation work, though, we have to really foster a culture where cross-functional collaboration is the way things work, not thinking about things in terms of our silos and in terms of our organizational chart. And that means when we think about how do we automate this process, how do we make decisions, how do we drive real-time insights and align to our business outcomes, what you find is that there's a horizontal flow, if you will, left to right, and that's completely opposite or 90 degrees to your oftentimes your organizational chart. Your organizational chart is built top to bottom. So this horizontal view that we're showing on the screen is really indicative of cutting across silos, bringing together a cross-functional team, bringing together users with the data sources and thinking about how do you create this speed layer to move beyond just reports, static reports, or perhaps not even ingesting the right data in the first place and leaving a lot of money on the table. So when we think about AI, we have to think about moving beyond basic chatbots. We have to think about moving AI into the space of your organization's workflows between data producers and data consumers. This shift requires us to think about people who are orchestrating and working horizontally across these silos. And for AI to be truly valuable and create the value, our data must be structured and clean and accessible. Remember, we talked about this earlier, garbage in, garbage out. So let's break this down a little bit more. In all of these industry use cases across all the 7, 8 industries that we've talked about and all of these examples in the webinar, we've really talked about the ability to ingest data. And that means you need to understand what data you have and where it is. If you don't know what you have or where it is, you can't bring it in. So understanding how you pull the data in, gather data from multiple sources, it's all about effectively capturing that data. And we gave a lot of examples in this webinar: customer interactions, operational logs, sales data. But all of those things are the atomic building block of AI impact. From there, that data has to be stored and enriched. Once ingested, data has to be accurately and organized in a way that makes sense, not only to humans, but more importantly to machines. So understanding that data from a data level and thinking about and factoring in security at the very beginning is critical. In this stage, you have to catalog your data, enrich your data, make it easier for compute, make it easier for AI and machine learning models to access that structured data. This is really the foundation where raw data is transformed into something more important, something more meaningful. Now we're going to talk about the next stage. The data then has to be published. It has to be made accessible. And that means not just put into a static report, but in ways that AI can leverage, especially generative AI. This stage enables timely data access, allowing different parts of the organization to retrieve it as soon as they need it. In this stage, data is primed and ready to be used. And then finally, there's the experience layer. Data is presented to consumers in ways that allows them to analyze, visualize, and share insights. This is where real value is created. And all of these stages enable AI to work seamlessly within your workflows. On the left side, you can deploy machine learning to be able to leverage algorithms on that data. And then on the right side, you can create generative AI applications that allow you to create value to data consumers. But no matter what, you must have a robust data pipeline allowing you to shift from research to action, cutting down response times and making data more than just an asset, but a strategic advantage. So, in that view, you start seeing how you can unlock the impact and the value of data. Deep, what comes to your mind here as I outline the basic building block of a data pipeline, but more importantly, think about it in terms of how these industry use cases unlock value for patients, for customers, and really for markets.
Definitely, Brian. So end of the day, it's all data. So how where the data is coming from, you need to have a plan to where to ingest the data and what you need to do with the data. So how do you pre-process the data? So is it batch data or real-time data, or is it split between two? And then what does business really cares about? So what I know with my experience, business cares about is how we are making it efficient, how we are saving money to the company, how we are automating things. So whatever you have shown here, data to action value creation is like end-to-end pipeline. You can say like a DevOps pipeline, which needs to be optimized. And for a newcomer coming in, he needs to know hey, this is the pipeline, and he needs to have knowledge on it. So here we need to take care is that the leadership needs to have proper person in proper place, who do you need to have it ingest, like a data engineer, whom do you have at the pre-process layer, so like that also can be taken care by data engineer. So then again, visualization, data visualization, how is it done, who do we need to have here? So one more thing I would put here is security, like how we're gonna see that all these are secured and in place with the organization rules. So these are some things leadership needs to be aware during the digital transformation phase.
Yeah, great. Well, some of the key lessons that we've learned throughout all of these conversations that we've been having is that really it's important to have the right people and more importantly, have a hands on approach to building out your speed layer to make it operational. Some critical lessons have emerged from that. Obviously, we've talked a lot about data and data quality. Secondly, what Andy Deep just said, security, building with security from the get-go, from the very beginning to handle sensitive information as things move to more and more real time. And more importantly, as data is leveraged for artificial intelligence applications, it's really critical to have that data built in, security built in at the data level. Another focus that we've learned is understanding what it takes to have real time response. Not everything has to be real time, it gets more and more expensive. But in that context, having a rear view mirror on historical data can only unlock certain value. So the idea of real time isn't really optional anymore. It's expected, but understanding that AI is a generative capability that's built on historical data is important. And that's why I think you're starting to see some more focus on synthetic data and being more clear on and testing more data use cases. Then there's transparency or explainable AI. Users have to understand that AI is making actions and recommendations that they can trust. And to be honest, most people don't. Not a lot of people trust AI and they don't want to outsource their thinking. The word artificial is a tough one in this context when humans are involved. You know, artificial intelligence seems to be the opposite of trusted and real experiences. But if you think of AI less in terms of artificial intelligence and more in terms of amplifying intelligence and the amplification of human intelligence, it can be a catalyst. And just like I said at the beginning, it can be a catalyst for great things, and it can also be a catalyst for things that don't work. So in that case, you know, you want to make sure you have explainable and transparent AI, and then everything is moving to more of a API driven application approach, more essential today than ever. API infrastructure is the bridge that ties everything together. So we've covered a lot of ground in our webinar today, and we're heading out of time. But one of the things that I wanted to leave you with is our enterprise guide for taking a practical approach to getting started with AI. you can go to digitalcommand.co/launchpad and download this guide. The guide provides a structured roadmap for you to understand and adopt and scale AI across 5 strategic phases. The first phase is really about just getting comfortable with what's out there. The guide is free to download. I encourage you to check it out and share with your teams. Anudeep, do you have any other words of wisdom before we let you go? I really appreciate your advice and context on all of these use cases and the real world application that you've had, not only as a CTO, but placing hundreds of people in some of the world's most fast moving and forward leaning companies. Anything else you want to share?
Yep. Thanks for putting it all together, Brian. So yeah, with the users, I just want to share that we as Kilo, we have helped many companies to transform from legacy software into cloud, like cloud migration, and then leverage cloud migration strategies to build AI applications end to end. So we specialize in that. If any help needed, yes, we'll be there to help any organization. And definitely, your book is recommended for leadership to take a go on the digital transformation and how it needs to be done and define the strategy. So all that, yep, I have went through your book, so that's perfect for them.
I appreciate it. Well, thanks so much, Andy D, for joining, and thank you everybody for tuning in. We'll see you next time. Also, check out my live show every Friday at noon Eastern at aileadshow.com. We'll see you next time. Thanks so much.
Yeah, thank you, guys.